Hello, welcome back to the Geographical Data Analysis video series for Geography 300 at WVU. The previous video on spatial autocorrelation looked at the test, Moran's eye, and a way of assessing with our inferential statistics and the significance values that comes from that to say, does my data have spatial autocorrelation? This somewhat shorter, I expect, video will be, so what? What happens if it is? Well, there is one, sometimes, as I said, we may just want to know that. It may be useful for identifying whether a new disease is infectious or has some other source. But then there's one other big so what, and that is this idea that we had that is an assumption of a lot of statistical tests that my observations, my data, are independent of each other. Okay, so the data is not independent. There is a relationship from one place to the neighbor. So those neighboring places cannot be considered as independent samples. The implications of that are probably not readily apparent. So let me follow on from this idea. What happens if my data are not independent? Okay, that basically means that my data is kind of behaving as if it is from a smaller sample. Okay, so my data, I have 55 counties in West Virginia. But because Mon County and Preston County are related to each other, it's not necessarily fair to say they are two fully independent observations. They might behave more like 1.3 observations. 1.3 is kind of weird, but that's how the math ends up going. And so I will act, as you've noticed, especially in t-tests, in ANOVA, and it came up in the chi-squared statistic as well. One of the elements is how big is my sample? I have 55 counties. Well, it might be, I really should act like it's 20 counties. Okay, so what if I need to act like it's 20 counties? That means I would need a stronger piece of evidence, so to speak, a larger value of the t-statistic, or a larger value of the z-score, a larger value of f for ANOVA, a larger value for chi-squared, for something to be regarded as significantly different from the null hypothesis. Because of that, so to be really precise, it might be where a t-value of 1.8 at 55 counties gets counted as significant. A t-value of 1.8 for 20 counties may not be significant. So we can end up say, by my threshold, 5%, 10%, 1%, whatever I've picked, I might conclude the null hypothesis is not supported by the data. I need to go with the alternative hypothesis when I should not reach that conclusion. That is the effect of spatial autocorrelation within our data. I might come to a false conclusion by saying the alternative hypothesis is supported when it's not. This is then something to be careful with, to be aware of. It's actually not commonly done that I have seen, but there are ways to try to assess what the actual or effective sample size ought to be in the presence of spatial autocorrelation. More commonly, and we'll see this when we get to regression, is to use techniques to try to account for this in their calculation, in how they reach their conclusion. Observing that, seeing that, that's still several weeks off. For now, be aware that this can happen. And as always, if you have questions, feel free to ask in the Zoom class. Send me an email. I'll be happy to talk with you at office hours as well. Have a good one. I'll see you at the next video.